Hi everyone, today we're going to be talking about chain rule. Now, before we jump into chain rule, let's review the topic of composition of functions. Recall that you can compose functions by taking one function and inserting it into another function. Say that f and g of x are functions, then the composite function f of g, denoted with this notation where you have f and g and like a circle in the middle, is defined such that f composed with g of x is equal to f of g of x. Example 1 says if f of x equals 7x squared and g of x equals 4x minus 1, find f composed with g of x. So f composed with g of x is equal to f of g of x. So if we replace g of x there, we get f of 4x minus 1. And that means that in our f function, anywhere we see an x, we want to replace it with a 4x minus 1. So that's going to look like 7 times 4x minus 1 squared. And so that is our composite function. Now note that this is something that we can take the derivative of if we wanted to. And there's a couple ways that we could do that. We could expand it, or we could use the product rule. So let's use the product rule. So if I expand it, or if I rewrote this, this would look like 7 times 4x minus 1 times 4x minus 1. And so the derivative then is going to equal 7 times the first function times the derivative of the second function plus the second function times the derivative of the first. I made this first bracket kind of big, and then if we simplify that and distribute in the 4, we get 16x minus 4 plus 16x minus 4. And then we have 7 times 16x plus 16x is 32x, and then minus 4 is minus 8. And then we can distribute in the 7 if we wanted to. So let's see, 32 times 7 is 224, so 224x minus 56. So this is our derivative. But what if we wanted to take the derivative another way? Well, the chain rule helps us do that. So let's take a look at the chain rule. If f and g are differentiable functions with y equals f of u and u equals g of x, then y is a differentiable function of x, and dy dx is equal to f prime of u times g prime of x, or equivalently, dy dx equals dy du times du dx. Now, something that is often thought of but is a common misconception is that in this last equation here, each of these components, so if I took a look at this thing, du dx, I want to comment, this is not a fraction. It looks like a fraction, but is not a fraction. And so each of these things, they represent a rate of change. So each of these things, they're not fractions, but they represent a rate of change. And so that's something to keep in mind when you're thinking about these types of problems and doing chain rule. Is it's really, I think, a poor choice of notation because students often think that like du dx, it represents a fraction, but it's not. It's not a fraction. It's just a poor choice of notation. It represents a rate of change. So keep that in mind when you are doing these problems. Example 2 says find the derivative of the composite function created in example 1 using the chain rule. So let's remind ourselves the function that we found was f composed with g of x was equal to 7 times 4x minus 1 squared. And if we wanted to find the derivative of that using the chain rule, one way that you could do that is you could think of the inner function as u equals 4x minus 1. And so we could say that f composed with g prime of x like that is equal to, actually, let me rewrite it without taking the derivative first. So let me rewrite it as 7u squared. And now, if we were to take the derivative of that, that would equal, we could use the power rule, so 7 and then bring down the power times u to the first power, and then we'd have to multiply this by du dx. And this is a 1, not a prime notation, so this is the number 1. Okay, so if we were to simplify that, 7 times 2 is 14. I'm going to replace the u back in. I'm going to substitute the u back in, and then I have to multiply that by du dx. So if u is equal to 4x minus 1, then the derivative of that is just going to be 4, because the derivative of negative 1 is 0. So I multiply that by 4. Okay, and that doesn't quite look like what we got in the first example, so let's simplify that further to see if we get the same answer. So 4 times 14 is 56. So I multiplied this number and this number together, and then from there, let's see, if we distribute the 56 in, 56 times 4 is 224 x minus 56. And this is the same thing that we got earlier in example 1 when we used the product rule. So the chain rule gives us the same answer as well.